How to iterate over rows in a data frame in Pandas. I have a Pandas data frame, DF. How do I iterate over the rows of this data frame? For every row, I want to be able to access its elements, values and cells, by the name of the columns. For example, I found a similar question which suggests using either of these. But I do not understand what the row object is and how I can work with it.
DataFrame.iteros is a generator which yields both the index and row, as a series.
How to iterate over rows in a data frame in Pandas? Answer: don't. Iteration in Pandas is an anti-pattern and is something you should only do when you have exhausted every other option. You should not use any function with iter in its name for more than a few thousand rows, or you will have to get used to a lot of waiting. Do you want to print a data frame? Use DataFrame.to_string. Do you want to compute something? In that case, search for methods in this order. List modified from here. Vectorization, Cython routines, list comprehensions, vanilla for loop, DataFrame.apply, reductions that can be performed in Cython, 2, iteration in Python space, DataFrame.itertuples, and iteritems, DataFrame.iteros. Iteros and itertuples, both receiving many votes in answers to this question, should be used in very rare circumstances, such as generating row objects/nametuples for sequential processing, which is really the only thing these functions are useful for. Appeal to authority. The documentation page on iteration has a huge red warning box that says, iterating through Pandas objects is generally slow. In many cases, iterating manually over the rows is not needed. It's actually a little more complicated than don't. df.iteros is the correct answer to this question, but vectorize your ops is the better one. I will concede that there are circumstances where iteration cannot be avoided, for example, some operations where the result depends on the value computed for the previous row. However, it takes some familiarity with the library to know when. If you're not sure whether you need an iterative solution, you probably don't. P.S. To know more about my rationale for writing this answer, skip to the very bottom. Faster than looping, vectorization, Cython. A good number of basic operations and computations are vectorized by Pandas, either through NumPy, or through Cythonized functions. This includes arithmetic, comparisons, most, reductions, reshaping, such as pivoting, joins, and groupby operations. Look through the documentation on essential basic functionality to find a suitable vectorized method for your problem. If none exists, feel free to write your own using custom Cython extensions. Next best thing, list comprehensions. List comprehensions should be your next port of call if 1, there is no vectorized solution available, 2, performance is important, but not important enough to go through the hassle of Cythonizing your code, and 3, you're trying to perform elementwise transformation on your code. There is a good amount of evidence to suggest that list comprehensions are sufficiently fast, and even sometimes faster, for many common Pandas tasks. The formula is simple. If you can encapsulate your business logic into a function, you can use a list comprehension that calls it. You can make arbitrarily complex things work through the simplicity and speed of raw Python code. Caveats. List comprehensions assume that your data is easy to work with. What that means is your data types are consistent and you don't have nans, but this cannot always be guaranteed. The first one is more obvious, but when dealing with nans, prefer inbuilt pandas methods if they exist, because they have much better corner case handling logic, or ensure your business logic includes appropriate nan handling logic. When dealing with mixed data types, you should iterate over zip dfa, dfb, ... instead of dfa, b, to _numpy, as the latter implicitly upcasts data to the most common type. As an example, if A is numeric and B is string, to _numpy will cast the entire array to string, which may not be what you want. Fortunately, zipping your columns together is the most straightforward workaround to this. Your mileage may vary for the reasons outlined in the caveats section above. Benchmarking code, for your reference. The line at the bottom measures a function written in numpandas, a style of pandas that mixes heavily with numpy to squeeze out maximum performance. Writing numpandas code should be avoided unless you know what you're doing. Stick to the API where you can, i.e., prefer vake over vake_numpy. I should mention, however, that it isn't always this cut and dry. Sometimes the answer to what is the best method for an operation is it depends on your data. My advice is to test out different approaches on your data before settling on one. My personal opinion. Most of the analyses performed on the various alternatives to the iter family has been through the lens of performance. However, in most situations you will typically be working on a reasonably sized dataset, nothing beyond a few thousand or 100k rows, and performance will come second to simplicity/readability of the solution. Here is my personal preference when selecting a method to use for a problem. For the novice, vectorization. When possible, apply list comprehensions, itertuples/iteritems, iteros, Python. For the more experienced, vectorization. When possible, apply list comprehensions, Python, itertuples/iteritems, iteros. Vectorization prevails as the most idiomatic method for any problem that can be vectorized. Always seek to vectorize. When in doubt, consult the docs, or look on Stack Overflow for an existing question on your particular task. I do tend to go on about how bad apply is in a lot of my posts, but I do concede it is easier for a beginner to wrap their head around what it's doing. Additionally, there are quite a few use cases for apply as explained in this post of mine. Python ranks lower down on the list because it takes more time and effort to pull off correctly. You will usually never need to write code with pandas that demands this level of performance that even a list comprehension cannot satisfy. As with any personal opinion, please take with heaps of salt. Further reading. 10 minutes to pandas, and essential basic functionality, useful links that introduce you to pandas and its library of vectorized/Pythonized functions. Enhancing performance, a primer from the documentation on enhancing standard pandas operations. Are for loops in pandas really bad? When should I care? A detailed write-up by me on list comprehensions and their suitability for various operations, mainly ones involving non-numeric data. When should I not want to use pandas apply in my code? Apply is slow, but not as slow as the iter family. There are, however, situations where one can, or should, consider apply as a serious alternative, especially in some groupy operations. Pandas string methods are vectorized in the sense that they are specified on the series but operate on each element. The underlying mechanisms are still iterative, because string operations are inherently hard to vectorize. Why I wrote this answer. A common trend I notice from new users is to ask questions of the form "How can I iterate over my df to do X?" showing code that calls iteros while doing something inside a for loop. Here is why. A new user to the library who has not been introduced to the concept of vectorization will likely envision the code that solves their problem as iterating over their data to do something. Not knowing how to iterate over a data frame, the first thing they do is Google it and end up here, at this question. They then see the accepted answer telling them how to, and they close their eyes and run this code without ever first questioning if iteration is the right thing to do. The aim of this answer is to help new users understand that iteration is not necessarily the solution to every problem, and that better, faster and more idiomatic solutions could exist, and that it is worth investing time in exploring them. I'm not trying to start a war of iteration versus vectorization, but I want new users to be informed when developing solutions to their problems with this library.
First, consider if you really need to iterate over rows in a data frame. See this answer for alternatives. If you still need to iterate over rows, you can use methods below. Note some important caveats which are not mentioned in any of the other answers. DataFrame.iteros, DataFrame.itertuples, itertuples is supposed to be faster than iteros. But be aware, according to the docs, Pandas 0.24.2 at the moment. Iteros, dtype might not match from row to row. Because iteros returns a series for each row, it does not preserve dtypes across the rows. Dtypes are preserved across columns for data frames. To preserve dtypes while iterating over the rows, it is better to use itertuples, which returns the met-tuples of the values and which is generally much faster than iteros. Iteros do not modify rows. You should never modify something you are iterating over. This is not guaranteed to work in all cases. Depending on the data types, the iterator returns a copy and not a view, and writing to it will have no effect. Use DataFrame.apply instead. Itertuples. The column names will be renamed to positional names if they are invalid Python identifiers, repeated, or start with an underscore. With a large number of columns, greater than 255, regular tuples are returned. See Pandas docs on iteration for more details.
You should use df.iteros. Though iterating row by row is not especially efficient since series objects have to be created.